Grade 11's Euclidean is very easy, okay? I'm going to be covering a question that has a Euclidean question that is a combination of our center theorems, cyclic quad theorems, and I'm going to show you exactly how easy it is, showing you a few tricks and hacks that you can use and that is applicable for almost every Euclidean question. So let's get started. We have 9.2. We have P, Q, and R are points on the circumference of the circle with center O. Now, before you begin, it is so important to actually annotate onto your diagram. Okay, so if they tell us that P, Q, R, and S are all on the circumference of the circle, well, we can obviously see for ourselves that P, Q, R, S is a cyclic quad. Remember what a cyclic quad is? A cyclic quad is a four-sided shape that touches where all four sides of that shape touches the circumference of the circle. Okay, so a cyclic quad doesn't always have that bow tie shape within it. Sometimes it kind of looks like a rectangle, but it has to touch all four sides of your circle. Okay, so that is very important. Okay. So now, I want you to write down a list for yourself. If you have identified a cyclic quad, you need to write down all the cyclic quad theorems, right? So when we think of a cyclic quad, one of the Euclidean theorems that we think of are opposite angles of a cyclic quad are equal to 180 degrees. We usually use that theorem when we want to calculate second angle. So in this case, for instance, we know that PSRQ is a cyclic quad, meaning like P plus R will equal to 180 degrees because of opposite angles of a cyclic quad are equal to 180 degrees. What else do we think of? We think of exterior angle of a cyclic quad, meaning that the exterior angle, first and foremost, guys, we don't even have an exterior angle. We don't really have an angle that is at the exterior of the cyclic quad. So it's not going to apply, right? But if there was, the exterior angle was going to equal to the opposite interior angle within that cyclic quad, but it's not applicable to this specific question, okay? One other one that we think of is we think of angles in the same segment. Now, we can definitely apply angles in the same segment to the specific questions. We first need to identify that segment, the segment that we're actually looking for. We need to identify that bow tie shape, right? So we can clearly see that bow tie shape right over here. Okay, so we've identified it. So that means angle P is going to equal to Q because of angles in the same segment. Okay, we can clearly see that P and Q are in the same segment, thus they're going to equal to each other. And please just mark them off as being equal to each other. So that means angle Q is also going to equal to 3x. And angle S is going to equal to R. Now, please do not make the mistake of thinking that the entire angle S is going to equal to angle R. No, that is completely wrong, guys. You need to highlight that bow tie shape. When you highlight that bow tie shape, it falls only to this part of the angle, okay? So we know that this part of S was going to equal to R. So you need to be very careful when it comes to that part. Okay, so you also want to go back and mark that off. Mark off S as being equal to R. So we've marked that off. We're done with that. Now let's continue on. They tell us that on the circumference of the circle with center O, if they mention anything about there being a center, I want you to also write down a list. Write down a list for each and every single piece of information that they've given you. Okay, so you need to identify our radii. We need to identify our diameters. We need to see if line from center to midpoint of chord is applicable. We also need to see if angle at center twice as much as angle at circumference is also applicable. Let's start off by identifying our radii. Now, a lot of students don't even know what a radius is, guys. Now, at this time of the year, I'm pretty sure you guys are familiar with what a radius line is, but let's just go back and review that. A radius is a line that stems from the center and touches the circumference of the circle. So OP is a great example of a radius. OP is a radius. It stems from the center and it moves and it touches the circumference of the circle. Okay, a radius always has to touch the circumference of the circle. Okay, so we know that all radii in a circle are equal to each other, meaning OP is a radius, meaning OP is going to equal to OS, and OS is going to equal to OR is going to equal to OP, because all radii in a circle are equal to each other. Now we see something that we can actually apply to this specific question. We see that POS is a isosceles triangle? Okay, so we can clearly see that triangle POS is an isosceles triangle. So remember, guys, an isosceles triangle is a triangle where we have two equal sides, meaning that angle P is going to equal to the entire angle S because of opposite angles equal sides. Okay, so anytime you see that, anytime you're able to identify an isosceles triangle, please make sure to remember your rule, your Euclidean, your geometry rule of opposite angles equal sides. Okay. So that means this entire S angle is actually going to equal to 3x, by the way. So you just want to mark that off as 3x. So now let's go ahead and continue. What about a diameter? Are we able to identify a diameter? Yes, we are. Remember, guys, a diameter Remember, guys, a diameter is a line that runs through the center of a circle, right? It runs through the center of the circle, and it is made up of two radii. We can clearly see, if you look at the diagram, we can clearly see that PR is a diameter. Now, one rule that's so important that is very unique to a diameter is that a diameter will always subtend a 90-degree angle. What does it mean to subtend? To subtend, when a line subtends an angle, it means that that line holds that other angle to the point where it reaches the circumference of the circle. So if we have a diameter, that diameter will subtend a 90-degree angle. So the angle that the diameter subtends is going to be 90 degrees. Let's go back and identify the angle that PR subtends. We're going to draw a pen, so we're going to trace it all the way to the other end of the circumference. It ends on this point. Do that on the other side. Trace it, trace it, trace it, trace it, trace it. Ends on that side. Since we know PR is a diameter, we know that this entire Q angle is going to equal to 90 degrees because of angles in a semicircle. So that's very important to remember, guys. Once you've identified your diameter, please mark that the angle that diameter subtends as 90 degrees because of angles in a semicircle. Okay, now let's continue on. What about line from center to midpoint of chord? Does that theorem apply to this specific question? Now, let's just review this rule a little bit, okay? A lot of students actually forget about this rule a lot. But basically, when we have a line that stems from the center, and if it splits a chord into two equal parts, that means that that line that stems from the center is perpendicular to that chord, meaning that there will be a 90-degree angle between the chord and that line. And that's when your line from center to midpoint of chord theorem will apply. It also applies when you have a line that stems from the center. If it is perpendicular to a chord, that is also when that theorem is applicable. That means that that chord will be split into two equal parts. Okay, and please do not confuse this line with a radius, guys. This has nothing to do with a radius. This has something to do with just a normal line. And let's say the normal line should look like this, but it does not touch the circumference of the circle, because if it touches the circumference of a circle, that means it would be a radius. So it would look somewhat like this. Remember, guys, a chord is a line that cuts the circle into different segments. The segment would just be a space. See, you can see this is a space. So if we had a chord and we had a line that stemmed from the circle, and if there was a 90-degree angle between that line and that chord, then yes, that's when that theorem would apply. The other way around, if we had a line that stemmed from the center, and if we had a chord over here, if that chord was split into two equal parts, that means that there would be a 90-degree angle between that line and the chord, and that is exactly when the line from center to midpoint of chord theorem would be applicable. So that's very, very important to remember. But in this case, it is not applicable, guys, because all of the lines that actually stem from the center are all radii. Okay, so it's not going to work. What about angle at center twice as much as angle at circumference? Is that specific theorem applicable to this question? Now, this is a quick little trick I want you guys to use, okay? So that you never get confused about this ever again, okay? So, the very first thing is you have to identify the arc that subtends the center, okay? What does it mean to subtend? It means that that arc should hold that angle, okay? So now let's start off by identifying the arc that subtends angle the center O, right? So we're going to trace the lines that stems from the center, trace it, trace it, trace it, trace it, trace it, trace it. It ends over here. We're going to do the exact same thing on the other side. We're going to trace it, trace it, trace it, trace it. It ends over here. So we know that arc PS subtends O. Okay. So the next thing that you want to do is you want to go back and identify. You just want to identify your angles that are on the circumference and go back and identify the arc that subtends those angles. Let's start off with Q. You're going to draw a line that until it reaches the circumference of the circle, draw a line, it ends over there. Go on the other side, do the exact same thing on the other side, draw a line, draw a line, draw a line, draw the line, it ends on this side as well. So it looks like it is also subtended by arc PS. So that means angle this center over here is basically it's they basically are subtended by the exact same arc, meaning that angle at center twice as much as angle at circumference will be applicable to this specific question, right? So what you want to do is you just want to annotate that, make note of it, write it on a piece of paper so that you don't forget that, because that might come in handy a bit later on when you're actually going through the question, right? So that's very, very important to remember. Okay, so now let's start off with the question. Express each of the following in terms of X, giving a reason for your answer. SQR. SQR. So SQR is this angle over here, this angle right over here, okay? So remember, we've already marked off SQR as being equal to 3x, okay? But why did we mark it off as being equal to 3x again? Well, that's because of angles in the same segment. Please remember that it is in the exact same segment as P, okay? So that means that obviously P is going to equal to Q, meaning that SQR is going to equal to 3x because of angles in the same segment. Okay. And for the next question, 9.2.2, and please make sure you actually annotate that onto the diagram. 2, calculate the value of PQS in terms of X. PQS. QS would be this angle over here. Okay. So now PQS, it forms a part, it forms a part of the larger angle, which is Q, angle PQR. So what method do we use to find out what that little part of Q is equal to? Now we already know that the larger angle Q, the entire PQR angle, is equal to 90 degrees because of angles in the same segment. So we can formulate a little equation for ourselves because we already know what the entire angle's value is and we know what a portion of the angle is equal to. So if we just formulate an equation for ourselves and say that the entire Q angle equals to 90 degrees because of angles in the same segment, remember, we say that PR is the diameter and a diameter will always subtend a 90-degree angle. So it's going to be 90 degrees equals to 3x plus this Q part of the angle, which is PQS. Okay, which is PQS. You're going to take the 3x over onto the other side, leaving you with 90 degrees minus 3x, and that's going to be your answer for question 9.2.2, guys. And please make sure that you annotate it onto your diagram. So you're going to write it as, you first have to state that this entire angle Q equals to 90 degrees because of angles in a semicircle, and then you're going to use that exact same method where you formulated an equation, meaning that PQS is going to equal to 90 degrees minus 3x. Okay, so what you want to do is you just want to go back and annotate that onto your diagram. You're going to write it out as 90 minus 3x. Okay, then for the next question, 9.2.3, we have to calculate the value of PSQ. 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 Okay, so you need to just go back and highlight this part, guys. It's very important to remember. PSQ. PSQ is the small part of S. Now, guys, please remember, guys, if you are required to calculate a small portion of an angle that already has a value, okay? So remember, we're looking at angle S. The entire angle S has a value. We said that the entire angle S equals to 3x. We've marked them off as being equal because of opposite angles equal sides, okay? So we know what the entire angle's value is, and we also know what a small portion of that larger angle is. You're going to use that exact same method where you have to formulate an equation for yourselves, okay? So you first want to see that the entire angle S equals to angle P because of opposite angles equal sides. And we know that S is equal to 3x. For that reason, it's equal to 3x, okay? And we know that the entire angle S, has x in it. So we have x plus the small part that we're trying to calculate, which is PSQ. PSQ, okay? So you want to take it over onto the other side. X minus 3x is 2x. So for that reason, S is going to equal to 2x, okay? And by the way, guys, you might be thinking why we didn't start off with R, because you can clearly see what, according to the colors, I've marked off S as being equal to R because of angles in the same segment. The reason why you shouldn't have started there is because we don't know what R's value is. Just use the method, guys. If you need to calculate a small part of an angle and we already know what the larger angle's value is, please just formulate an equation for yourself, okay? So now, when you're actually writing this down as your answer, you first need to say that PSO, this entire larger angle equals to 3x. It equals to 3x because of opposite angles equal sides. Then you're going to formulate that equation that I showed you previously, where you say, and then you're going to say PSQ equals to 2x. And that's exactly how you're going to get to your answer. Okay, then for 9.2.4, we have to calculate the value of PRQ. PRQ is this angle over here. So we've marked off PRQ as being equal to this small part of S because of angles in the same segment. Remember, we stated this previously. We said it's because of angles in the same segment. So you're just going to annotate that and mark that off as 2x. And obviously, guys, when you're writing this out as your answer, you need to say that PRQ. Don't just say R, guys. A lot of students make this mistake. You're going to lose marks. You cannot just say R. You need to state the full angle. P, which is PRQ, equals to 2x because of angles in the same segment. That's exactly how you get your answer. Then for question 9.2.5, calculate the value of QPR. QPR. Now, here are a few rules that I want you guys to use, a few methods that I want you guys to use, a few hacks that I want you guys to use before you even approach a question. Go back and ask yourself, does P equal to any other angle directly through Euclidean theorems? So when I'm referring to Euclidean theorems, I'm referring to maybe angles in the same segment, tan chord. I'm pretty sure you guys are familiar with these theorems, tan chord, those theorems. If it does not equal to any other angle directly with Euclidean theorems, then we need to think of all the other general geometry theorems that most people do forget about, right? Like exterior angle of a triangle, like sum of angles of a triangle. Now, sum of angles of a triangle is a theorem that you should always think of. Now let's look at the triangle that P is in. If your angle's in a triangle where you have the values for both of the other angles, then you need to use sum of angles of a triangle. So we know that P is a part of PQR. We know the value of Q is 3x. We know the value of R is 2x. So we can easily use sum of angles of a triangle to calculate what P is equal to, right? So those are the few theorems that you have to think of first. So you're going to go back and say that angle P, don't even just say angle P. You need to state angle QPR plus Q plus R equals to 180 degrees, right? Because of sum of angles of a triangle, you're going to substitute PQR, which is angle Q, as 90 degrees. Do not substitute it as like 3x plus 90 degrees minus 3x. No, we already know its numerical value. If you already know its numerical value, you want to substitute that in. We know it's 90 degrees. We're looking for, we already know what R's value is, guys. R's value is 2x, and we're actually looking for angle P, right? So you're just going to write down an equation for yourself. You're going to go back and say, and when you take everything over onto the other side, you're going to have 180 degrees minus 90 degrees minus 2x. Okay, which is going to 180 degrees minus 90 degrees is 90 degrees, and then you're going to be left with minus 2x, and that's going to be your answer, okay? But you first have to state your rules, guys. You have to state the fact that it's because of angles, sum of angles of a triangle, and then you're going to get to your answer of 90 degrees minus 2x. Okay, guys, we're done with this video. Make sure you go over this question over and over and over again. We're going to be posting more videos every single day, so make sure you go back and practice this question. As for now, we'll see you in the next video.